Hello, welcome. Today let's try to solve Leetcode problem 2642, design graph with shortest path calculator. So we are just giving a class. Inside the class, there will be init, add and shortest path. Yeah, we basically need to calculate the add and shortest path. And we are giving a graph with a number of nodes. So here, this 4 means there are 4 nodes, and inside the array, there will be edges. So this is just from the start to the end and with a weight of 5, for example, 0 to 2. And this graph is a directed graph. So 0 to node 2 with a distance of 5, and for others, it's the same. And we can also check the return for add as it will return a noun. And for sorted path, it will return the sorted path. So for example, 0 to 3, the 0 to 3, the sorted path will be -1 because there's no sorted path. Yeah, let's take another example. If we add 1 to 3, so 0 to 3, the sorted path will become let me 0 to 1, 1 to 3, so the sorted path will become 6. From beginning, it is the sorted path is none. 0 to 3, after add, so the sorted path becomes 6. So for such problem, I think the easiest way is by using the Floyd Warshaws algorithm. Basically, it is a dynamic programming. Because we are going to calculate the distance between any two nodes. If we are going to calculate from the source or add, normally we're gonna use the Dijkstra's algorithm. And let's check the number of nodes. It is 100. It means n cubic is enough to pass for the time complexity. But we need to take care of the add. After add, we need to update the graph, but how we can update it? So this is a little bit tricky for this problem. Now let me just start coding. So I'm going to prepare a graph. So inside of the graph, it will be inf times n for r in range n. So this is just a matrix, and we're gonna use this matrix to prepare the Floyd algorithm. And now we are having a graph, and I also need to prepare some variables. Self.n should equal to n. And after preparing the graph, so self.graph would be equal to graph. Now I'm going to check the graph. So for I in range n, the I should be equal to 0 for as for UV in address, du v should equal to w because it is a directed graph, so we don't need to prepare d with v and u. Now we are going to use the 3 loops. Basically, it is a dynamic programming to prepare all other edges, the sorted distance for all other edges. So for m in range n, for I in range n, and for j in range n. So the distance from I to j should equal to the minimum of distance I to j with the I to m and plus the distance from m to j. So this is for preparing. Just inside the initialization, we need to prepare something like this. After preparing the graph, we need to use this self.n and self.g. Let me first finish the sorted path. Because this is gonna be easier. So we can just return self.g with node 1 and node 2 if this is not equal to infinite. Otherwise, it's gonna be -1. If it is not equal to the infinite, else it will be -1. This is according to the question. If there's no path, so the sorted path will be -1. If there is, we're gonna return self.g with node 1 and node 2. Here would be also node 2. Yeah. Now let's go to the hard part. So we are going to add the edges. How to add the edges? It's gonna be just yeah. Let me use this g should equal to self.g. Self.g is a graph. Yeah, let me just use the graph. Now we have three edges, UV and W should be equal to edge, and GUV can update to this W, but this is not finished yet. Because this is only one edge, we need to update all other edges, which is related to this U or V. Yeah, if there are some edges related to this U and V, we can get a smaller result maybe. Yeah, but now we need to check with the current distance. Yeah, so before we are giving this to W, we have to check. If it is bigger, we're gonna get a wrong result, but we need to check. Yeah, so the distance is d, u, and v. If the current distance is let me check, is less than or equal to w, so this means yeah, if I were to update this w, but it is bigger and equal to my previous result, my current result, I need to have a return. Yeah, because if it is bigger, if this weight is bigger, yeah, let me use more than uh, more than and equal. Yeah, if it is more than and equal, if this weight is more than and equal to the current weight, I just need to return because I don't need to update the weight. Yeah, if it is if this weight is less than the current weight, it means I might produce some shortest path, smaller result. Yeah, let me just copy the code from here. Yeah, because for here it's basically update everything. Yeah. Now I think it will be okay. Let's just check it. The edge is not defined. Yeah, here will be edges. This n is not defined. Where is this n? Yeah. Yeah, I'm gonna here. Gonna prepare this n should equal to self.n. Yeah, it seems something wrong. Yeah, let me check why it is wrong if this weight is more than and equal to the GUV. I'm gonna have a return. Otherwise, I'm gonna check the minimum. the n should equal to self dot n. Yeah, I don't know why. Yeah, it means the shortest distance is wrong. I returned some wrong shortest distance. Yeah, let me add a tag first. Normally I don't believe. So if m equal to v or m equal to u, I need to update the result. Yeah, it is still wrong. Yeah, it should be not equal to infinite. If it is equal, I'm gonna return a -1. Yeah, let me try to use more than. Why? Yeah, something wrong. Yeah, if the weight should be more than. Yeah, if the weight is bigger, I need to return, and then I will update it. Yeah, let me try to use self.n here. Let me check the code why it is wrong. I just finished writing, it is okay. Now it is wrong. Everything is just wrong. Let me copy the add as part. Maybe I think because of this areas. Yeah, I'm not sure. Yeah, let me just comment this one and check what's gonna happen if I use the previous code. Yeah, it's still wrong. It means my initialization would be wrong. Let me copy the initialization code. Yeah, it means my initialization code is wrong. So let me check. Yeah, let me check which is wrong. So here the infinite times n for r in raise n is the same self dot n duv should equal to w, and for I in raise n, the I should equal to 0, and mic Yeah, I didn't find what is wrong with my initialization code. I think this one should be okay. Let me just uncomment this one and delete it. Now I'm going to comment my code. Yeah, it seems my initialization is wrong. Even though I don't know which line is wrong, I have to check one line, yeah, one by one. So I prepared the self.n and this graph j and self.z equal to z. Yeah, for I in raise n. Yeah, I think the only difference is 0 to n. And yeah, that is no difference actually. Maybe I need to change those two lines. Basically, I don't think it would have any influence because it's only the sequence. Yeah, only the sequence is different, but the result would be the same. Yeah, so sometimes even I have to use the template every time. If I don't use the template, I got wrong even. Uh, yeah, and I cannot find which line I got it wrong even like that. Yeah, let me check one by one character, one line by one line. Yeah, let's first check the graph inf times n for r in range n. Yeah, self.n equal to n here. Yeah, and here for I in range the I equal to 0. Yeah, there's no difference even I use a 0. Yeah, because it is the same. Let me add this 0. Yeah, it's just a string. I don't know which line. Yeah, I don't know which line I got wrong. Yeah, it means there must be some line. Yeah, let me just use compare to check which line I got wrong. Compare text online. Yeah, let's try to use a div to check what is wrong. It's really strange. Yeah, so sometimes I believe, yeah, there must be a typo. I didn't find which typo is wrong. Uh, so I'm gonna, yeah, put everything in the right place and compare the text, which line is wrong. Yeah, so I say I am empty. I am empty. Yeah, I don't know why I have to compare with the initialization for my code, but definitely there must be something wrong with it. Uh, yeah, let me use a deep checker to check the difference for those two areas of code. Basically, yeah, I have to copy. Hmm. Yeah, I think inside of the deep checker, I can find something. Yeah, yeah. Let me find the difference. What is wrong? This W is wrong, and this equal is wrong, and the last line is also different. I think this W is also okay. Oh, here I used the double equals, so this is why. Yeah, so sometimes there's a typo. If you didn't find it, you're gonna totally get it wrong. Yeah, let me fix this typo. So Let me delete these areas and fix this typo. Yeah, this is quite annoying. Let me submit it. Yeah, now it seems okay. But yeah, the hard part is about here. I didn't explain it. So for this m, so this is totally the same. I just copied it from here. But for this m, after this for loop, yeah, we need to check if this m equal to v or if this m equal to u. If it is equal, it means there is a shortcut. So we're gonna update the I to z. It can be any difference, but in between, it goes to this v naught or it goes to u naught. We have to update the result. Now let me submit it. Yeah, there are some better ways to update it, but I prefer to use this one because yeah, because this is what I think when I find this problem. What I do, I think, oh, it maybe can use this way, and it actually works. So I used this shortcut to update the distance. As you can see, it works, and yeah, it is still okay. Thank you for watching. See you next time.